A little bit about Mark. He's the CTO of FileTek. He's Executive Vice President and CTO of FileTek, focused closely linking the storage management technology and R&D investments to the most pressing and high-value customer requirements. He has over 20 years of experience in design, development, and delivery of enterprise software. And he has experience in business process automations at companies such as Verity, Autonomy, Cardiff Software, and NCR Teradata. So with that, I'm going to hand this over to Mark Seamans.
Thanks a lot. See if you guys, can you hear me without me standing right next to that? I hate doing that presentation where you stand like the whole time, like right up there. If I can avoid it, I'll walk around a little bit, hopefully keep your attention and keep my attention as well as we go through this. What I'm going to talk about today, and as Molly mentioned, I'm speaking today on behalf of an organization called the Active Archive Alliance, and I'll have just a quick slide in just a second here on what the Active Archive Alliance is and where we're focused and what we're doing. And as Molly mentioned, she's the chairman and really was a conceptual founder of that organization, which now has a lot of member companies that are involved in it, all around this topic of big data storage for long-term use. And again, we'll talk today about architectures, technologies, the problems that we're trying to solve, and how people are going about solving them. So this is going to be not a product pitch, but really a business problem pitch and some anecdotal discussion about what people are doing and how they're tackling these problems out there. The Active Archive Alliance was actually founded in 2010, so it's a few years old now, and while it doesn't seem like it's really old, one of the things you find is that I think most organizations, when you'll see a press release on something, and hey, this new thing is getting going, and a lot of the shelf life of those things tends to be a year and a half, if that, and then it's kind of dead and it fizzles out, right? It was somebody's great idea with a press release, they put it out, and then it lost momentum, and this certainly has momentum, the Active Archive Alliance. There's meetings, there's people that are involved, and I think it has momentum because the problems that the Active Archive Alliance is working on solving are relevant problems that more and more and more organizations are looking to deal with, and you'll see what those problems are and how we're working to help people tackle those. But the focus of the Alliance is really on, as it says here, focusing on best practices, education, awareness of large-scale storage alternatives. And when I say alternatives, it's the alternative to just buying more disk, expensive disk, from the guy who's been selling you expensive disk for a long time. Not to say it's a bad thing, but it may not be the only way to do it. It may not be the most cost-effective way to do it, right? It's like getting to the grocery store. A Formula One race car will get you there, right? But is it the way you have to do it, or for that problem you're trying to solve, is there probably a different way that looks a lot like a Formula One race car, but is more appropriate to that problem you're trying to solve? The other thing that goes on with the Active Archive Alliance is interoperability testing, demonstrations, and reference architectures. For example, we're preparing right now for the Storage Networking World Show that's going to go on in a few weeks, and one of the things that we're doing is we've got several of the member companies of Active Archive Alliance together, putting together a whole Active Archive solution with heterogeneous equipment, with hands-on labs that people that attend that session can go to and actually touch feel one of these systems and do some exercises to kind of go, hey, how does this feel and work? And really the benefit of that is really just increasing everyone's awareness and exposure to this Active Archive technology. And what Active Archive, and I will go on record, and Molly knows this, so I'm not speaking behind her back here, I don't really love that term, Active Archive, right? It's kind of me, it's just like, archive just seems like the dusty place where you put things, right, that are hard to get to. It's a self-storage facility that you're mad you've been paying on for the last 4 years and you haven't gone there to get any of your stuff out. And really what this is, in terms of your data, is nothing like that, right? Active Archive is really what it's about, is providing an affordable, and I'll actually say kind of cost-rationalized or right-costed method for storing all of your data, all of your creative data, and the key of the piece of that is forever, right? And many times as people implement Active Archives, if you ask them, hey, how long do you think you're going to need to keep this stuff? They'll pause for a minute, they'll kind of go, I don't know, I'm going to keep it forever. I don't know if I'm going to need it in 2 something in place where the option is there that I know if 10 years from now I need to get back to this, I can go, I can grab it, and I got it back. And so the idea is it allows them to have all of their data online all the time for use in supporting critical business activities. Because we all know that just like that self-storage facility, once you take things and you put them somewhere where it's difficult to get to them, right? They're on tapes, and you have to go to the tapes that are not online because they were written with some proprietary software, and so now getting back to that and untarring or restoring that data, it's going to be a big problem, right? We're not about that. What we're about is, hey, I want to get that data, oh, there it is, and as Molly mentioned, within a minute or two, you're at your data and you're working with it. So what I'll talk about today is really this problem in a nutshell, the core challenges that it creates, because they're much bigger problems than just, I'm going to have a lot of stuff. It's not just about I'm going to have a lot of stuff. It's about I'm going to have a lot of stuff. The world's changing underneath me in terms of storage technologies. I got to store this stuff forever, and I'm not going to be able to triple my IT staff to be able to get all this done. We're going to talk about the key solution elements. That there's really three big pieces, in my opinion, that come together to make this whole thing happen. I'll talk through a few customer use case examples, and through this, I think you'll kind of get a checklist of things you might think about as you would go to tackle one of these pieces. So, storage reality, and I think that, again, I heard this in Molly's presentation reference. If you look at the dates along the bottom of this is just one chart of many we can all see, so I'm not going to harp on this for a long time. We're in that 2013. So somewhere in there, we are in the midst of this hockey stick of increases in data. And it's when I see this increase in data going on, and kind of where I think this big data comes into play, it's not in PowerPoints and Microsoft Word files and emails, right? I mean, that's probably increasing, but it's not increasing that much. What this data growth tends to be is what we're seeing is purpose-oriented data that's occurring as the byproduct of some activity, which is throwing off tons of data. In genomic sequencing, right? It's the fact now that we have genomic sequencers that used to be able to generate, a few gigabytes a day of data because the images were lower resolution. It took a lot longer to generate one sequence of data, and therefore you ended up with a lot less to deal with. Now, just like everything, right, the sequencers are faster, they're higher resolution. What used to be one image, now they can spit out 50 images, that each one is 50 times the size of what it used to be, and you really want to keep all of these because it could be valuable information. It's video surveillance data. It's the byproduct of people walking around and just carrying a cell phone, and you've got all this transactional data of people being tracked of where were they, what were they doing as they walked around, what were they near. So we've got a huge amount of data. We've got a variety of storage technologies. We've got tape-based storage, disk-based storage, cloud or object-based storage, as was talked about in the last session that's emerging. And then what I'll call, and this is a big piece of what we talk about with Active Archive, NBT, the next big thing, whatever that is, right? The NBT. And there's always going to be an NBT. Even when the NBT comes, there's always another NBT that was right behind it. We just couldn't see it, right? Because the one was coming right at us. I mean, I go to IEEE conferences sometimes. People are talking about holographic storage, and hey, we're going to be able to have this little piece of cube. It's like ice, and it's going to have 86 exabytes of data in there. Just throw it in your pocket. It's kind of the Steve Jobs, right? When he announced the iPod originally, right? Thousand songs in your pocket type of thing. And who could have conceived of that? I could never have conceived. I worked at a company called Teradata in the 90s, and I can remember putting together database systems for customers that were from here to the back of this room of disk cabinets, and we were rolling out a terabyte of data. Whoa! Who could ever use a terabyte? Now my son, right, could fill a terabyte, in his little Mac of just, music that's getting created and videos they make with their GoPro when they're at the beach, and all of a sudden, wham, terabyte gone. That again on a hard drive. Crazy, right? So we got to be thinking about NBT. The other thing we have to be thinking about with NBT is not just new technology, but it's media migration and consolidation, right? Who cares if a piece of media, right? Sometimes I don't think who cares. Maybe I care a little bit, but when someone says, "Oh, this will last 30 years," right? This piece of media. 30 years, my God, in 30 years I'll be able to take a room full of those and fit them on something this big. If I'm still holding on to those 30 years from now, something's wrong. And active archive is about how do I consolidate that stuff over time to continue to take advantage of the MVC. So we've got growth requirements, technology evolution, but we have to accept the reality that we've got existing applications and processes out there. So as the object stores are coming along, that's great. But guess what? All my users aren't just going to wake up tomorrow and plug into the object store. They're working with what? They're working with file shares. SMB file shares in Windows. They're working with NFS file shares for their applications. And so we got to find a way to give them access to this great stuff while their applications can continue to work. And the last piece is, at least the clients that I work with, IT groups are 110% utilized, right? Everyone's already got a full plate, so they got to figure out how do I take care of this. So let's look at the storage reality and the piece of this problem that we're looking to solve. And kind of, as I work in this at FileTek, I divide the world kind of into, you've got to simplify life, right? I divide the world into kind of two buckets, if you will. There's data being created, and there's data being used. It's the data that was created. I don't know if you ever have seen imagery. Let's think of this. If you're looking from satellite views of Hawaii, right? If you look at Hawaii, there's the Hawaiian Islands, lush, beautiful Hawaiian Islands. And then if you look, there's a little edge of the island, like if you ever go to the big island of Hawaii, you go to one edge, and guess what? There's steam coming out of the water, and it's where the new island's being created. Right? It's still bubbling, and there's new lava coming out, and every day there's another little bit of island that's created. Active Archive targets the island, not the new island that's being created today, right? I think the new data that's being created today needs the high IOPS, the high capability to be able to churn and burn and analyze and receive it, put it down. And then what we need is the other half of the story, which is this green box data. All that data, which was created 20 minutes ago in some cases, 5 days ago in some cases, 6 months ago in some business cases, but it needs to be stored and accessible for your business. And so I drew this picture here where the green box is bigger than the blue box, and that's kind of by definition, right? Because if I create a terabyte today, tomorrow I have a terabyte, and then I create a new terabyte tomorrow, and now I have 2 terabytes I'm carrying along from my green box data. And if my blue box, I start generating more data, well, guess what? Every day I got to still keep that stuff. And so even as blue gets faster, green grows with it. And so typically as we get involved with active archive discussions, what we'll see is people will start to realize, ooh, here's my blue box, but now I've got this much green box. It's okay. Just going to buy a little more disk. Everybody, no big deal. We got our budget, we got a little extra budget approved, and we're good. But somewhere between here and here and here, people go, whoa, this is not working anymore for me, right? I can't just, and it may be data center space, it could be a lot of reasons that you can't do that. Time to think about a new way. And we get to this breaking point. And I kind of have broken this down over conversations that we've had into 3 reasons that you typically end up, and even people have all 3 of these things going on, but usually there's something of these 3 that became the reason you got engaged in a conversation. Number 1, oh my gosh, my budget's out of control, right? If I look ahead, it's going to be 140% of my budget to buy the storage I need for the data that we have pumping out of the new equipment that we just bought. And I don't have 140% of budget. It doesn't work. So how can we do it maybe a different way? Give me some help here. Another one is the old way doesn't work anymore. Hey, our 7-day weekly backup, we just realized is taking 13 days. Doesn't work anymore to do the backups that way. How else could I tackle this problem to be able to take a new slice of this? And this whole backup restore thing is a key piece of this. There's also RAID that goes on, right? RAID rebuild times with 4 terabyte drives, and I lose a drive, and how long does that take to rebuild? So some of these IT processes are what cause people to look at this. And then the other one is the uh-oh moment that somewhere along the line, somebody at one of these organizations went through a data migration project and realized that either data was corrupted, it was lost along the way, something really bad happened as they went through that, and they're going, this is so frustrating, I don't have time to be doing 600 terabyte migration projects, and I know next time, as we get the next new storage in, it's going to be 2 petabytes, and no one gives me extra time to do this. Is there a system I could use that could take care of that for me over time? So the reality check is the way things have historically been done, really for varying people at varying points, and I think for a lot of organizations we're at the cusp of more people realizing this, is not going to be workable in this area of big data. And so active archiving is about what I'll call right costing, my term, and flexibly deploying your storage within your organization to meet the specific requirements of your organization, right? Active archive isn't about selling you a box and saying, here's the box that solves your problem. It's about saying, here's a strategy and a set of technologies and tools you can use to solve the problems of data durability, right? Data access, availability, and performance. And the question was asked at the end of Molly's presentation about, well, how do you know if the data went bad, right? And that's a problem that active archive solutions often will take into account, in that into the data that's being stored, as you mentioned, it's injecting additional data. It's injecting checksum data that can make the data self-validating, so that as you access it, you can look at it and say, has this been corrupted since I put it there 2 years ago? And you're not just going to take bad data and pass it along. And then performance is the other one. And we'll touch in here for a little, I have a slide in here, I think, on the whole tape, because I think tape gets a bad rap in a lot of this sometimes, because tape can play a really interesting role in this active archive solution, but not tape for backup. It's a different use of tape. It's tape for online data access. And the thing that you need to be aware of as you do that is just taking in mind performance, right? Do you need it in a millisecond, or is it okay if you could get it in 45 seconds? And if you can live with 45 seconds, you may be able to cut 85% off your storage cost to be able to blend different storage technologies into your mix. The other piece, as you look at this, is kind of the interesting thing about archive data versus backup data. If you look at backup data, over time, backup data, not much time goes by and backups become worthless. It's like, when you go back to that backup, I got a newer backup than that. They're kind of rolling off the end in terms of their value. Archive data, though, as we take this and create this online archive, not backups, but just I can get to my data if I need it, say it kind of looks like this, right? And the reason I drew the squiggly line, or the reason I stole this slide actually from Molly, I really liked it, was that data is never as important as the minute that you need it, right? It was completely unimportant, but then you had this aha moment, oh, I wonder if I can correlate these 5 things. I want to look at this stuff, and whoa, the value of this stuff goes up as long as you can get to it. And that's kind of this chart representing that. For any given piece of data, it has varying value over time, and it's very unpredictable, right? If a new algorithm comes along and you want to go back and look at some old genetic sequence data, take the new algorithm and analyze it, that data that may have been sitting there for 3 years suddenly is hot stuff. So when we break this down into kind of the chunks, maybe to think about as you look at active archiving, it's more than just storage. It's a complete approach, a process approach to this forever file management. And I'll break it down and I'll talk briefly about each of these. One is analysis of what you've got. 2, migration of what you have into this active archive environment. And then the last piece, not the least important piece, critical, but is the management of that information kind of over time. But I think sometimes people get so focused on, I'm going to build this big, enormous store that we're going to put stuff into, that they lose track of, okay, once I get that built, all my stuff's sitting over there, and I need to figure out what stuff could I put in here, and how am I going to get it over here, and know that I got it, and where did it go? And for the people that used to look for it over there, how do they find it over here now? All the real things that you have to deal with as you go through this kind of an integration of a new storage approach. So first piece, kind of analysis. What do you have? And there are numerous tools. I grabbed a screenshot from one tool, but SolarWinds, makes some good tools for this. Many storage vendors make good tools for this, so I'm not espousing one tool over another for this. I like the phrase that says, a problem well understood is more than halfway solved. And so before you jump to, I'm going to start moving stuff, why don't you understand what you have so you can start to make some decisions about the policies you're going to put in place for how things are going to get stored. So what you might want to look at is the data about your data. So like this chart is showing slicing across time on the bottom. When was data last accessed? When were files that you have last modified? So you're going to get a picture of, if I were going to draw a line, and let's just say I said, if stuff hasn't been accessed in over a year, okay, how much of my data would I be able to move into the archive and free up on my primary storage, right? New space. I don't have to buy new primary storage because I can move that data off into the archive. It's still accessible, and now I've got freed up space on my primary environment. But it may be by modified date, by access date. You might want to slice it by file type. Wonder what those files are. And this is another view that tools can give you. What are these files that are sitting out here? This view is by file size. Do I have big files? Do I have small files? And if I were thinking about, what if I just moved my big files that were just bigger than a gigabyte? How much data could I chunk off? And so you start to figure out, okay, let's see, if I did this and this and this and this, I could move a whole ton of my stuff off of here. So that's the first piece, is understanding what you have, where it is, and how it's being created. How much of this new data is showing up every day from the systems you've got in place that are generating it. The next piece is data migration and data movement. And this is key, and I think I have this on this next slide. This is an area I have seen so many people struggle as they go to implement solutions like this. And it is absolutely a process. It is not a project, right? And the people who take it on as a project are doomed to failure, right? If you go to someone's home, I guarantee you, and they've got a beautiful yard, and you look out there, God, gorgeous, flowers, bushes, trees, grass. That did not get that way because 2 weeks ago they said, I'm going to build a beautiful yard most of the time, right? It's just over time. They worked on it a little bit all the time. They're mowing it, they're trimming, they're putting things in, they're thinking about it. And that's really what this data migration project is, what you have to tackle these with. Because you're going to end up with this archive you're going to put in place. You're going to end up with, and I'm not going to pick on anyone in particular, but you've got storage, tier 1 primary storage, super high, fast storage that's sitting out there. And the question is going to be, how do I find the jewels? It's like finding gold in the ground, right? That are here, or oil under the surface of the earth. How do I find the right stuff and get it over to here? So I've got my analysis that I did, and now I got to whittle through that and find those nuggets and move them. And so what you want to look for is data analysis and migration. If you visit the Active Archive website, it talks about different companies that produce this kind of technology. So things that you can point it at what you've got, it'll draw all the beautiful charts and graphs, and then it'll let you build policies for moving that stuff out and putting it into the new system. And the other piece you need to keep in mind, in some cases, this may not matter for you, but for some people it may, is the idea of you've now taken it off of here and you've moved it here, but people are going to look here in many cases, right? And so you need to figure out how are they going to find it. So it could be a memo that you send them, hey, we moved a bunch of stuff. Or it could be that you build in to your migration plan the ability to put links in place for things that were migrated, so it points them to, hey, that stuff that used to be there, you get it over here now. Everyone's kind of got their own opinions on links, and I'm not going to pound the table and say it's always the greatest thing in the world, but it can be a necessary thing to help people find their data.
Is there a standard for some kind of a dictionary, like a data dictionary, index? Because over a 20, 30, 50-year life of a company, you might want to go back to 20-year-old version or something and know where it is. So is there a standard for this index for active archiving?
That's a great question. So it's, yeah, is there an index standard? I don't know that there is not an index standard per se, but I will 100% say that many of the technologies you'll see that go after solving this problem provide across the board what I'll call enterprise versioning capability. So that what you can do is you can have your current real-world version of the Active Archive that's right now, right? I go out there and here's what it is. But there may be portions of that tree that have evolved over time. Research projects where new versions of reports were generated. And what you want to be able to do, someone may come to you and say, you know what, I need this whole set of data, but I don't need it the way it is right now. What I needed was the way it was 2 years ago when Dr. Rabinowitz was here and her lab was working on this research. Can you give me a view? If I could just get back to that, man, that would be hot. And so they have this almost like Fury's and Mac with Time Machine. It's an enterprise time machine where you've kind of got the real world view, that's your J drive, and the systems will be able to say, I can give you a K drive that is last October 17th at 4 in the afternoon. And then you can use it, and then when you're done, you say, hey, I'm all done, and they go, and it didn't really replicate all that data. What it really just did was set up the metadata the way it was that day at that time, and under the hood, as you put new versions in, unlike a regular file system where when you copy into an inode-based file system, a new version of a file, it just flats right over the top of the old one. These systems go, oop, new file, okay, keep the old one, make the new one visible, then I'm going to make a time slice over time of the old versions that are going down.
And I could buy that today from who?
You could buy that from me.
Good, all right.
So, but I'm selling Active Archive today, so you can see me afterwards. So invest in your migration approach. I call these sometimes science projects, and people who take this on, roll your own migration projects. And I work with clients. I mean, there's smart guys, and these, I do have clients that use this stuff and it works, and they love it. They'll write rsync scripts, and a whole ton of rsync scripts that are moving data around and doing all their migration for them without any kind of pre-built tool to do it. And that they have time to do it, and they have smart people, and it works great for them. I have also seen people who went that route, who figured out 8 weeks into something that, whoa, my script stopped working 6 weeks ago, and it's been logging stuff, but I never went and was looking at that, and guess what, we haven't had stuff moving for 6 weeks. And so I say just because it's initiated with a cron job, it doesn't mean it's a process that's working. Just because you're kicking something off every night at midnight, it doesn't mean it's a well thought out process. So consider these key capabilities as you look for migration tools around manageability of that process, the audit trail you get, reporting, alerting, throttling so that it doesn't just overwhelm your network as it moves gigabytes of data and just goes 100 threads, right? And all of a sudden your network goes down for some reason. Can you tune how much load that's in place? And then this last piece I touched on, link support. So it's got a little checklist to think about there as you consider migration. Then when you think about file access, I put this little slide together to think about, okay, what does that mean for a user? What we're trying to get to really is ideally, where when the users are going to access their files, one of two things are going to happen. Either a user is going to just go to the file system exposed by the Active Archive, grab the file they want, pull it out, and go. It's just a J drive. No big deal. No training required. Or if they want to get to it from the place where it used to be via the link, ideally you'd like to do that where no special software is required here anymore, and you've just got a user who says, hey, I'm going to go grab my file, which has now been replaced with a link, and what happens is their system, kind of unbeknownst to them, resolves that link. It points them to the place in the Active Archive where the file is. The file comes back and it's open on their machine. Now, what I just showed you there tends to work well for onesie, twosie access. Right? Oh, I just want to go and I want to pull a handful of research files down and we're going to work on those. I put a couple of slides together, again, on tips of things I've seen that work well or where people have struggled. One of those, and Molly touched on it and was brought up, I think, in some of the comments around small files, right? Small files are going to be your death if you think about storing things for 10, 15, 20 years, right? Seeing tons and tons and tons of dinky little XML files and things. If you say I'm going to have 26 billion of these out in this active archive, is tough when you think about migration and metadata management, and that's where Molly had talked about. Once you get above a certain size, in many cases, it's not the size that kills you, it's the number of discrete metadata objects you're trying to manage that becomes unwieldy. And so, one thing I would look for is look for solutions. If you think about people that have used tape over time, right? You hear this concept of tarballs. What did people used to do? Oh, we'd take all the files, we rolled them up into a tarball, and then we put the tarball out onto the tape, because tape would do well with streaming large amounts of data. Once you get that machine going, it's really fast for putting out large chunks of data. So you don't have to be as big as these massive, 200 gigabyte tarballs, but look for things that have the capability, if you have lots of small files, for rolling those into bigger chunks and then storing the bigger chunks. But what you don't want is for a user to have to ever have any awareness of that, right? You want a user just to be able to grab their file, and the system can go and go, oh, the file you want is actually in this bigger chunk. Let me grab that bigger chunk or index into that little piece that I need and pull it out. But over time, as you do media migration and over long-term system management, having those bigger files that you're working with that contain, almost like zip files, a bunch of smaller files will be good for you. The other one is, and I've seen this with clients as well, is that if you're going to be pulling a whole bunch of stuff out for a Hadoop analysis or big analytics, I have seen clients who put a process in place around that don't wait for a user to go in and say, hey, I want to go copy out, whatever, 400 gig or 5 terabytes of data. They'll say, hey, I'm going to give them a screen, maybe a Ruby on Rails application or a little web application I can put together to say, hey, tomorrow we're going to be wanting to do analytics on this data, and go. And it can kick off to the active archive a message that says, hey, we're going to be working with this data that may be somewhere deep by policy, how it's stored in the archive, and can you resurface that for me temporarily to a fast place, so that while I'm working with it, it's super fast. So move it up to more expensive disk, I'll work with it for some period of time, and then when I stop working with it, you can just toss it from this expensive disk. It's not that it took it from the tape, maybe, and migrated it permanently up to fast disk. It just took it off the tape, made a working copy for you. In this area, you could do some work with it, and then have dynamic cache management such that once it stops being used, it kind of falls off the bottom. So just think about that ability to stage data or pull data back as a capability. If you're going to end up with a lot of stuff in an archive, you'll probably be doing some of that, particularly if you want to get the cost advantages of using something like tape, right? You've got to put a little bit of process around that to get those. There's some cost to getting those cost advantages. So the last piece of this that I will touch on is the management piece. So we've talked about migration, a little bit about management. We've talked about the analysis of the data and some of the challenges there. The last piece is actually the management of all this data. And I think, as we talk with clients sometimes, and people who are exploring Active Archive, one of the things that gets missed is all the value that gets bundled into a lot of these Active Archive solutions, right? As you get into managing stuff forever, there's a tremendous number of things that IT has to take on. And what a lot of these Active Archive solutions do is pre-build a lot of the functionality that gets into the software. So, first of all, what it does is it allows you to take, disk, and kind of any kind of disk, and maybe lots of different flavors of disk. Not espousing any one type disk, but just saying, hey, if you've got RAID, SAN, NAS, you want to be able to embrace that as part of your Active Archive. Cloud-based storage or object-based storage. I kind of differentiate with these being this is someone else's hosting it, and this is object-based storage that you may be hosting yourself, right? Examples of things over here being things like maybe CleverSafe, Amplidata, Scality, and a lot of these object stores that you can purchase and deploy on your own. And then tape, right? Putting in there. Library-based tape. We're not talking about an auto changer where these tapes are all going to go sit on the shelf. That's not what we're talking about. We're talking about automated tape access where you can have online, right, petabytes and petabytes and petabytes of data that are at your fingertips with robotics to build it. When you need that data, it goes and grabs the piece of tape that you want, puts in the drive, and it starts streaming it back. But the idea here is that you take all of this and you wrap it around just labeled storage. That's what Active Archives do, is they take it all and they make it so that you as an administrator can just work with it as labeled stuff, storage, right? This tape file, SSDs, and the next big thing coming along. And again, from anybody, not picking one or another on here. I grabbed a couple of slides, these are Active Archive slides, to kind of talk as well about the importance of this data failure that you brought up. Because it's a big issue that I think gets swept under the rug sometimes in terms of what's going on here. It's because it is, when they use the term silent data corruption, it's silent. Data is going back. I will guarantee we all in this room have lost data. It is lost. It's gone. We don't know that it's gone. That's why it's silent. It will be silent until we go to access it and it's corrupted. And then it's no longer silent because we'll be screaming, saying, whoa, that file's bad. I wonder how long it's been bad. And if you look here, these numbers, if you're not a math person, they don't look like they're that different, right? But if you look at consumer grade SATA, your chances of having a bad sector on a drive is 1.0 e to the 14. We all remember back to that, right? We were in high school math and it was e to the something. Well, enterprise SATA, e to the 15, enterprise SAS terminal 16, LTO tape 17, IBM and Oracle storage tech enterprise tape e to the 19. Oh, look, how much difference could there be between 14 and 19? No big deal, right?
Was there
A couple, five, right? By definition, five difference, 14 and 19. But when you look at how much data would you move before you have an error, right? And the thing about data corruption and silent data corruption is the errors occur, but you don't necessarily know that they occurred. It just goes, ding, bit flips, and there it goes. Bad. Used to be good, now it's bad. And so these numbers are kind of staggering differences as you look here, right? In terms of, and I have one other slide that shows how much, if you have like 100 devices going at once, how long could you run before you would really have a bit that was going bad. And the reason we see this, by the way, with disk and the numbers per tape are better, which make tape a really good alternative for very long-term data storage, is purely a real estate problem. When you look at drives, right, you have a 3.5-inch drive, and we're cramming. We all lived through it, right? We went from 500 gig drives to 1 terabyte to 2 terabytes to 3 terabytes to 4 terabytes, cramming on there. Well, the only way you do that is stuff gets closer and closer and closer and closer and closer together. It's magnetic stuff, right? Where the chances are something influences the thing next to it, a bit flips, and now that data's back. Well, tape doesn't suffer from that same real estate problem, as it turns out. Tape, while it just has more space on a tape, and so things that are this close on a disk are this far apart on a tape. So the chances of them interfering with one another spatially are far lower. So tape's got a lot of headroom left in terms of space in the parking lot before the parking lot is full to go. And these problems in terms of data going bad, in the case where they are detected, like a drive goes bad, get really scary, and you may have lived through these when you start to go into RAID rebuilds and things, right, where you know you've already lost one drive, and now you're trying to rebuild those drives, and that's usually when another drive decides it's going to go back. But if you look at the data, let's say we had 100 devices spinning a maximum transfer rate. Here's how long you would go before a bit or a sector would go bad with those, right? A couple hours probably for SATA, low-grade SATA. Enterprise SATA is a little better. Enterprise SAS gets quite a bit better. But when you start looking at some of these tape technologies, it's a lot better. And again, a lot of these will go undetected unless you have technology built in that's checking your data and fixing it as you go, which most active archive solutions do. So as the data is moving from piece to place, it's constantly looking at it and saying, is this data the same as it was when I first saw it? So you checksums and hash code validations and making sure, since we're going to save it for a long time, that it's still good. So back to our story here, you've got your storage technology at the bottom, and then what gets placed on top of this a lot of times, because you've got users that need to access this stuff as a NAS, is a NAS layer. Molly talked about a gateway layer that sits there, where people accesses the regular old NAS, SMB, or Linux, regardless of what's under the hood down here. And so you could be blending in your storage, disk, tape, cloud, whatever, and they're just seeing a regular old NAS. So it's one of the things it does, simple access. And I think going forward, you'll see more and more of these active archives also exposing, object-based interfaces, either using an S3 interface or the SNIA CDMI interface, just common interface. We'll just be able to do a RESTful interaction with these as well. Another thing that they do with an active archive that they take care of for you, this is a big issue, is blending the storage we talked about, but the migration of storage also is something that it'll take care of for storage administrators, right? Where a storage administrator can say, hey, I've been storing stuff on, let's say I've been using tape. I've been storing stuff on LTO5 tape for the last 3 years. I've got 1,800 tapes. And now LTO6 came out. Ooh, it's faster, it's got a lot more capacity, it's the new way. So I'm going to take in my same library, put a whole bunch of LTO6 format tapes in there. What I'd love to do now is to take those 1,800 tapes, and I'd love to move them to LTO6 format. I'd love to reduce the number of tapes that I have, revalidate my data, and kind of crunch that down to get the new best of the best. Well, Active Archives will take care of that for you by letting you as an administrator say, take care of that. And it may take 2 months in the background, you're working, kind of doing it, and all the while your users still have access to that system. And that's true as well for migrating from things like, disk to tape, or tape to cloud, whatever that migration is going to be going forward. It provides this framework for you to plug new stuff in and move things around. So all the while, as all that stuff can be happening down here, users have access to data. Administrators monitor what's going on with the system and tune those policies. And the other piece, and I'll talk just about a couple of them here, is that they're wrapped up in management functions that are provided. So what are some of these management functions? There's a ton of things that Active Archive Solutions do for you in terms of heavy lifting. We won't go through these, but a couple points. They provide policy management for things like version tracking that we talked about. Retention. If you want to say, hey, for these files that go in, if they go into this portion of the tree, what I really want is to say they cannot be deleted for 5 years. This is financial data or whatever else. And so this will enforce that for you. It can do storage replication, hash management. It'll do alerting if the system goes down to let you know what's happening. Disaster recovery management is another big piece. Interestingly, the reason I know that these systems are important to people, that these aren't a garbage can that people throw stuff in and they don't care if they can get to it or not, is because in increasing a high percentage, I would say 70% of the clients I work with now as we implement Active Archives are keenly interested in multi-site solutions and are keenly interested in high availability. It's how long am I going to be down if we lose a server? How long am I going to be down if we lose a switch? If something happens, right? Because this is important stuff and we cannot have outage for the users that are looking to get to this. This is the point we touched on in terms of that enterprise time machine, right? This idea that you can have a real-time view, what I call point-in-time access, and then you could put a K drive up from October 18th of last year, and maybe another NFS share from April 21st for a finance group that wants to see stuff. You can kind of have as many of these as you want. And it's this idea that you've always got the latest version of everything available for everybody, and if you need to get slices back from the past, you can do that. This namespace management, the idea that some people want to come at, you want one directory structure, people to get at it via SMB or Linux NFS interfaces and have permissions mapping between the two. I'm kind of belittling this. This is a really hard problem to solve, and good solutions take care of this so that you can actually have a tree and have users from different worlds getting at one version of your data. And then the last one is an audit trail, right? As if you're going to have something stored out here forever, what's important for you is at any given time to be able to go back and ask questions about that system and figure out, well, how did we get to the point where this is the way where it is? If it looks like data changed that's in the archive, can you tell me who changed this thing and when they changed it? When did this new data show up? If something's gone, who deleted it? When did they delete it? And so a lot of these good solutions will go and provide you with an ability to have answers to those questions that you can just delve in and take a look at. So all these kind of pieces go into putting one of these together. So let's analyze, migrate, and manage. So to kind of wrap up, talking through a few customer use case examples. This is Yale University is an active archive customer in their HPC, high performance computing data center. And from a big data analytics perspective, what they use their active archive for is genomic sequencers, right? They have a whole bank of these bulldog genomic sequencers that are just pumping out data all day long. And what they do is they pump data onto high-speed analytics servers, so this intermediate set of storage that they have. That data goes in, and it gets looked at by researchers, kind of preliminary work done on it. They kind of separate the wheat from the chaff and go, hey, these sequences are very interesting. We're going to keep those over here. These other ones we don't want to do anything with right now. Those slide over to the archive. But they do go back, and you can see in the statistics from the system of them pulling data back to do repeat analysis or then subsequent analysis on this data all the time. And it also provides them with cross-lab, cross-project visibility and use of data. This is another active archive implementation. This one is also genomic based, and the third one I'll do is non-genomic, but this is the National Institutes of Health in I think Bethesda, Maryland. But it's a huge data store, and essentially what this is, if you receive federal grant money from the United States to do genomics-based research, one of the things that you get as a requirement is please upload your data so that other people can make use of that in their research, right? That we're all sharing and getting this to go. So it's a huge data clearinghouse that's built on an active archive, 24 petabyte current system capacity. And currently this is high-speed disk based with tape library based for long-term storage. And they're one who right now is snapping in and doing their first work with cloud-based storage. And they're actually going to do hosted cloud because they have a huge pipe to an offsite cloud. And they're going to do it for two reasons. One is they get good pricing on that storage. And number two, it kind of gives them a built-in DR that storage is going to be sitting in someone else's data center replicated out there. So they kind of get disaster recovery and a whole bunch of infinitely scalable storage they can pump into from the archive. And then this one is a fun one as well. Different use of kind of a big data storage archive. This is a company up in the Boston area that's called Exos. I think coming from the term X's and O's of football. And what this company does, they're a media company, and they take all of the digital content, all the different feeds from every camera in HD from all of the different college football games. They actually do NBA games, they do hockey games, but they take all of this stuff and they stream it in, and then they make it back available for uses in sports video production. But they also license it back to teams preparing to try to crush the next team next week, right? So if you're going to go play Tennessee, you can say, hey, can I get the last 3 games with these 4 camera looks of Tennessee? And they can provide that to you, so you can do all those little coaches clicker things and try and figure out how are we going to beat Tennessee. But again, they had this huge exploding storage problem, and they've now put an active archive in place where they're keeping active data on fast storage that's getting analyzed all the time with this bulk green box storage that's growing up to the side. So to wrap up, key points about this and kind of the active archive. I think the value here is that with an active archive, it's really a set of tools that let you blend storage resources to meet your cost, performance, and assurance objectives. If you have really high performance objectives for a set of your data, then you can say, great, I'm going to pump a bunch of disk, and for that portion of the file system, I'm going to keep that data by policy on fast disk. Other things that haven't been accessed in a certain amount of time, great, those will be on tape. I can blend that with cloud over time and maybe dabble a little bit with cloud for certain projects and give that a try. So you get to pick at blending cost with performance to get the right mix for you. You can evolve those storage technologies over time, and the system takes care of all the migration for you. I think today this NAS-based approach allows for that quick deployment because not everybody's ready just to snap into an object-based application. I think they will over time, but I think now you can use the benefits of block-based and of object stores, but what users see is this convenient NAS. It provides this built-in capability for all the tough things that IT struggles with. I mean, it's not that IT isn't going to have to do these things if you don't go with this approach. It's just that they're going to buy 46 different tools to do them, and they're going to kind of cobble it together themselves. And the last piece from a recommendation is as you put these in place, to whatever degree you can, ensure that your migration policies are automated, managed, and that you're getting audit reports all the time to make sure this whole thing is a living system that continues to kind of go on its own. And if you'd like to learn more about these technologies, if you go to activearchive.com, you can go on there and there's white papers, links to the member companies that are in Active Archive, discussions about different products. There's a blog that's up there that talks about topics in Active Archive, so check it out. Any questions? Out of time. I'll be around too if people want to chat after.
Is data compressed before storing on the
The question is data compressed before? I think the answer to that is that's a product implementation and technology question versus an across-the-board thing. Like the tape libraries have built-in compression that you can turn on that'll automatically compress invisibly to you before the data goes on to tape. So if the tape has native format of 6 terabytes, you can get much more than that if you're using compression. Some applications do have built-in compression algorithms. And it also goes by the type of data. Like when you look at like genomic data or compressed video, it's already compressed, and so you don't get a lot for compression. So it's kind of byproduct. Yes?
Anybody using erasure codes to improve the ECC portion of it?
Yeah. So the question is anyone using erasure codes? And a lot of those technologies for the object store pieces, if you look at, again, like Skilly, CleverSave, Data, are erasure code based. And the other benefit you get when you look at those is geospread, right, where you can say, I'm writing to a portion of this cluster of storage nodes that's here in my data center, but it's going to probably replicate out to 2 other places where I can then start to turn the knobs myself to say, I want to be able to lose an entire data center and know that I could reconstruct my data using the erasure codes from what's sitting in those 2 other data centers. And so you don't have to do a full duplication 6 or 7 or 8 times, right? I think there's a lot of promise in that. It's a huge, one of the biggest emerging areas I see is that erasure code. Yeah.
Do you use any tiered storage systems to do a lot of migration, which are available now from a lot of companies in the software area?
Well, so the question is, we use tiered storage systems, and I would bet that some of those companies participate in this active archive market. And some people do it with tiering, where things go from fast disk to medium disk to tape to back, and it kind of moves up and down a hierarchy. Other companies take an approach that all the storage is peers. And if you need to get a file and it's on tape, that person makes a request, the data comes off the tape, and it streams through memory, through the network, back to that user and never touches disk. So those are some of the, depending on what you're doing in your app, different ones work differently. But I'll bet you some of the very familiar names in the tiered storage are participating in Active Archive Alliance.
All right, so we are up on time for lunch, and so we'll be breaking now until 1 o'clock. At 1 o'clock, we'll be coming back to the same room for